Hello everyone. I will stand awkwardly here because I'm going to show you a lot of demos. So my name is Henk Boelman, Principal Developer Advocate at Microsoft. So my job is to teach you all about how to build applications with our new AI tooling. And that is exactly what I'm going to do today. I want to start with talking a little bit about agents. How many times did you hear the word agents in the past 3 months? A lot? Yeah, me too. So does anyone know exactly what an agent is? Exactly. Now, I heard so many definitions last week about what an agent is. So I thought I will come up with the one I think is the best, and that is what I actually did here. So if I talk about agents, and in the context of today, it is a semi-autonomous software that can be given a goal and work to achieve that goal without you knowing in advance exactly how it's going to do that or what steps it is going to take to achieve that goal. So I think the past year, mostly you have been developing these type of applications, like you have a prompt, you send that prompt to the model generates a response, that response comes in some software, we do something with it, send it to the interface, and so on, and so on, and so on. But now, in the time of agents, we don't know exactly how that response is going to be coming to you. So there is an input, and basically your LLM decides which tools, which agents to call to kind of formulate your output. So if we look at agents, an agent has a model, like GPT-4o-realtime, GPT-4o, some llama models can be there. So it has a model. It has a set of instructions, and you give it a bunch of tools that can do stuff for you. And if we dive a little bit deeper, we kind of see here that we have the agent with the model and the instructions. There is a conversation, so a user message comes in. The LLM decides to use some tools. Some APIs support code interpretations, function calling, doing some RAG things out of the box, generates a message, sends that back to the assistant, and then you can chat with it. So basically, that is what an agent does. So that's a lot of nice slides, but let me show you a small demo of what an agent can actually do. So for that, I'm going to use the Assistants Playground in Azure AI Foundry. Yes, we renamed it last week. It was Azure AI Studio. It's now Azure AI Foundry. It's exactly the same thing, but it is not. So Azure AI Foundry has a little bit more tools. It includes Azure AI Search and a bunch of more tools, and includes everything that was in AI Studio before. So also the Assistant API, and on top of that, we've built a playground. So here I have an assistant that is going to help me analyze my sales data, because that's the use case here. So I have a CSV with all my sales for my fake web shop over the past months, over the past years actually. So I uploaded that. I enabled the tool Code Interpreter, so giving my assistant the power to write code on my behalf and execute the code. I gave it a bunch of instructions, like you are a sales assistant for Contoso, please be polite, professionally and very helpful and friendly. I tell it that it has access to my CSV file, give some examples what can be found in the CSV file, and then say what it can and can't do. So if I start and say help, it will tell me what it can do and how it can help me. So let's pick this one and make it, what is the total sales revenue for each region in the year 2023. I'll start looking in my CSV file, analyze my data set, it's writing a little piece of code for me, and it comes up with what my sales revenue is. Pretty cool. But this is a list. I really don't want it in a list. So I can say, put it in a graph, please. Always be polite. So we will see that it will start reasoning again. It's going to write a little bit of code here in Python for us to create a graph with matplot. And bam, here we have one. But yeah, I don't really like these colors. So I can say change the color to red. And it will write some new code. And bam, here we go. So now we can talk, interact with our data. And this is just a simple example of what you can do with it by enabling the code interpreter that can write code for you. So this is an example of a type of agent you can easily build yourself using the playground. So let's talk a little bit more about the agent. So we have the model, instructions, or in other words also called system message, and we have tools, in other words sometimes also referred to as function calling. So I want to zoom into two important things that will kind of help you with creating your agent. So the first thing that you have to understand is the power of your system message or your instructions. And I have a very basic example here. Like if I would ask any plain model about what is your name, it probably answers completely random. I don't have a name, but you can call me assistance. How can I help you today? Depending on the model, it will respond in a way to you. But if I put in my system message, you're a friendly agent called Henk, you always respond in a rhyme, the agent is going to respond very different to me and telling me my name is Henk, nice to meet you, here to help you what you need to do. So with 2 lines in the system message and the extra instructions, I gave the assistant a personality, like my personality, always good, and I made it respond in rhyme. So I completely changed the tone of the model. So this is all nice, but I think you want to hear what this model can do. So here we are in the real-time audio playground. So I'm using the GPT-4o real-time preview model, and they're becoming longer, and I have to hit escape. Real-time audio playground. I have the deployment, and here I have my system message or model instructions and context. So every model it is kind of named a little bit differently, but basically it does the same thing. So if I would say here, hello, how are you today?
Hello, I'm here and ready to help. How about you? How's your day going?
So far, so good.
Great to hear. How can I assist you today?
So this is how it will respond out of the box. But what if I put in, oh, nope. Where are we? Sorry, we need to have the auto typer installed because nobody wants to see me type this whole system message. Here we are. Here I'm saying you are an AI assistant, you love to talk about raccoons, only raccoons, you have your favorites, and you dislike someone else, some other types not much, and you are rude and a bit funny. Mostly goes okay, mostly goes okay. So if I click again and say, hello, how are you? Oh, wrong. Hello, how are you today?
Oh, hey there. I'm doing all right, but I've got raccoons on my mind as usual.
Okay,
You know, those brown ones
I
from up
don't,
north are
stop,
just the best. But don't get me started on those light gray-striped ones.
Stop. I don't like raccoons.
Well, that's a shame. Raccoons are fascinating creatures, especially those brown ones from up north. They're clever.
No. I like the ones in the south.
Oh, really? Well, I suppose everyone's entitled to their opinion, even if it's a little misguided. I mean, sure, the gray-striped ones from the west.
Okay, you can have a lot of fun with this GPT-4o real-time at home. But you see, like, what I put in the system message is so important for how the model responds to you. So that is one thing I wanted to talk about. Then the second thing I want to talk about is function calling. And this is the way how you can give your model kind of the power to do tasks on your behalf. So it is giving the capability to LLMs to take user-defined functions as inputs and generate structured outputs. So how does that work in code? So on one side we have your code, and the other side we have the LLM or kind of the Azure OpenAI API. So your application calls the API with your prompt and the definition of your functions. So you define a function in JSON and that the LLM can call. Then the LLM will decide, based on the prompt, the input and the system message you sent it, which function should be called. And it will return that function to your application with the function that needs to be called and the parameters. And then you have to write in your application the logic that execute that function with the given parameters. And then finally your application will call back to the API with the prompt and the output that your function has generated. And then the LLM will form the response and you send that back to your user. So let me show you how that actually works using a GPT-4o voice application. So here we are in GitHub Codespaces. So here I have my application. I made an application that can talk about products, can manage my agenda, knows about me, knows about time, and can send email. So the first thing, it is actually running. Looks like it is running. Yes. So here is my front end. So I can ask it something like, start listening. Hello, how are you today?
I'm doing great, thank you. How about you? How can I help you today?
I'm going on a hike. I need some warm waterproof shoes. Can you recommend me a few?
For your hiking adventure, I recommend the Trail Walker hiking shoes and the Trek Ready hiking boots. Both are warm, waterproof, and designed for durability and comfort on the trails. Trail walkers have a breathable mesh lining
Okay,
and
good enough. Send me the product details from the first product you mentioned.
I've sent the details for the Trail Walker hiking shoes to your email. You should receive it shortly. Happy hiking, Henk.
My name is Henk. Okay, we will wait for the email. So here is the email. And it has sent me all the details from that hiking shoe that was also in that product documentation. Then, okay, thank you for sending the email.
You're welcome. If you have any more questions or need further assistance, just let me know.
Yes, let me make an appointment for next week. Which
All right.
days am I still free?
Next week, you have the following open slots. Monday, December 2nd, before 3 p.m. and after 5 p.m. Wednesday, December 4th, before 11 p.m. Thursday, December 5th, after 11 p.m. Please.
Okay, schedule it for Wednesday, please.
Sure, Henk. What time would you like to schedule the appointment for on Wednesday, December 4th? You have availability.
Make it 10 a.m.
Your appointment is set for Wednesday, December 4th at 11 p.m. If you need anything else, feel free to ask.
No, that's fine. Thank you very much.
You're welcome, Henk. Have a great day.
Okay, so this is what you can do with function calling and a system message and GPT-4o real-time. So let me show you now how I made that application. And it was actually not that much work to do that. So first of all, I made a connection to my email and my calendar with a Logic app. So it's an API call that just returns my agenda, and it is a Logic app that creates an agenda item for me. So I'm calling those two APIs. Then I have a mailer send account that will just send out email for me. And yeah, that's basically what it does. It sends out email for me. And here we see the logs of what it all did. And there is a small rack application there that kind of finds my products. So let's start with the list of all the tools that this agent has. Okay. So first, here we start in app.py, where I have my system message, where I tell it is a voice-enabled AI assistant and that it should keep the messages kind of short, because you don't want to have like an agent that does blah, 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 blah. So this is the first instruction I'm giving it. Then I'm instructing how to execute some of the tools. I give some extra guidance. You can decide to actually add it in your tools or do that in the system message. For me, it worked better this time to put it in my system message. Then I gave it some extra guidance here. It was kind of hard to make it work with time zones, because time zones are always hard. Your agenda comes back in UTC. We are here in CAT. So I gave it some instructions how to handle that, and then how it should send and formulate my email. I have a list of tools here. These are basically my tools. I'm adding those tools all here to the conversation. Some of them I give some parameters, some of them I give some parameters to connect to my Azure AI Search, some of them don't need anything. So let's go first and go into, what shall we do? Let's go into the search. So this is how you define a function. So what you do is you tell it in the description, in kind of a prompt, what the function's purpose is. Then you define the properties and describe what needs to be put in the variable by the LLM. So you kind of have to do a little bit of reverse thinking. You describe what you want to have in these parameters. And then the LLM will try and put the values in those parameters for you and returns that to your application. So here you define it, you give it a name, the description, and the parameters, the properties actually here. I have two tools in here, one for the actual search and one for the one that kind of puts all the documentation back into the front end. It's my vector search. I'm just doing a basic vector similar. When it decides, oh, I'm looking for shoes, it formulates a search query, executes that in the background in Azure AI Search and returns it to me. I have a product index here. We can have a whole hour of discussion how you will get your products nicely chunked in Azure AI Search. But the quickest way is using the built-in vectorization of Azure AI Search now. So you basically point to a blob storage where your documents are, and Azure AI Search will handle everything for you, the chunking, the vectorization, and everything for you. So it went very fast. So if we look at my database, here I have like all the product information nicely in chunks with the 1536 dimensions of the OpenAI vector. Yeah, so there are 164 documents in here. The next thing what we can do is kind of look how it would send an email. So if I would ask, please send me this email, it will invoke this tool. And the tool has the description, send an email to the current user of the agent, which is the result from the product search. So I didn't tell it my email address. It actually called the function get current user to retrieve my email address to do that. So then it put that in, the name, the email, the subject, and the body. So here the result from the product search, so it knows how to put it in there. And then it is just the implementation here with the parameters. Name, email, subject, and you can handle this as any of your code. And you can actually also test this, like an independent function, like with some user tests and so on. Then the current user, now I just return my name and my email address here. But you can hopefully imagine that I can be logged into this application and that this function would retrieve my user data. Current time, it will just returns the current time because LLMs are not very aware of time. So you need to make a function. You can choose to put it in your system prompt. You can choose to do it in a function because the function will be called in kind of real time. So you have actually the real time. The system prompt can be a little bit behind. That is up to you what you want to do. My agenda is a function that says gets the whole agenda of the current user, returns a JSON object with all the appointments, calls the function, and returns the raw output of the JSON back to the LLM, and the agenda item will just create an agenda item for me. And then of course there is a front end that kind of sets up, opens the WebSocket to the backend and starts streaming audio back and forward. So that is kind of all what is to it. Defining functions, give those functions to the LLM application and start building with it. So I think it is time now to open the floor for some questions.
Here, everyone, please raise your hands. Let's start in the front.
So why did you decide to do the? Well, thanks for the talk, by the way. I really enjoyed it. So, but why did you decide to? How do you decide what to do in a function? And so, for example, with the email, you could also get the current user from your system. So now the AI does 2 calls. Why would you want to do that?
Because in this case, it also greets me. I can also ask it, what is my name or what is the current user? So having that function there can serve multiple purposes.
But isn't the trade-off that it will get slower, for example, or I'm not sure? Every function call, does it have to do something? Does it cost something?
If it is correct, then if it is called once, it is in kind of the conversation of the AI already, so it just has to call it one time. I don't think it is going to call it like 10 times. But yes, if you would do that, it can be more expensive indeed.
This side, and then I'll switch to the next one.
Hi, thanks for your presentation. I'm also using AI to get responses. What I notice is I get different responses very often. Is there a way to programmatically prevent that from happening so that you get a very, or as much as possible, similar answer to a similar question?
Yeah, that is the question everyone wants to have answered, right? So by nature, these things are non-deterministic. So it is kind of a feature that it does not. What you can do is help in your system as its guide the conversation to a way that you want it. So lowering the temperature, lowering the p-top value will kind of help in the predictability of your LLM, but will never give you like a guarantee of that it will exactly respond the same way. So, but by putting a lot of instructions in, like what I've done here, for instance, like always use the following step-by-step instructions to respond. It mostly does it. So the more explicit you are, the more likely it is that it will respond the same way. But no guarantees.
So we saw indexing and grounding based on documents.
Yes.
For example, I would want my chat to be grounded on an internal documentation that's hosted on a website. Would that also be a possibility?
Yes.
All right.
I know you want to know how, probably.
Yeah, but it's
Oh, there are so many ways to do it. You can use the Bing connector. There are, if it is a public-facing website, you can use Bing search. There are some tools already there where you could just call the Bing API in one of these functions. You can decide to index everything, put it in your Azure AI search. You can, if it is a small website, just feed it some documentation in Markdown files to see if it will actually give you the right answers before factorizing. So there are many ways, and it really depends on your website and what type of questions you want to have asked, how you would connect it to your thing. But for instance, using Copilot Studio, there are a lot of predefined connectors. And I always say that is a very good tool to start and see what all is possible before you start diving into all the code yourself.
Yeah, first of all, great presentation, thank you. My question is, when you asked it to send you an email, you said it first retrieved the user data and then sent the email. As far as I know, currently, like at least in the documentation, the OpenAI function calling method and schema doesn't allow for subsequent like chaining function calls. In this demo, how did you do it? How did you implement the, like, do you keep the function results in a context, like common context somewhere?
The LLM actually decided here. We can see what it. Can you read it? So here we see what the LLM has decided to call on its own, basically. So I just gave it a list of these are all your functions that you can call, and then here it said first get the current user and then send the email. Then it sent the email. So the LLM decided the order to call the functions, because I had in my description for my function that sends email that it needs the current user data. So it interpreted that, oh, I have to call that function first. I can't call this function until I have that current data, the current user, because I can't fill the required properties for that function yet. And that worked for me in this case.
Okay, so currently, if we use the same methodology, the same OpenAI function calling, then we can say, okay, gather data from this resource, this resource, this resource, and compose an email and send it to me, which would require, like, let's say 4 function calls. It would be able to do it right now.
Yes, if you describe it well in your system as it's in there, it should be able to do that.
All right, thank you.
You're welcome.
Any more questions?
Did you at any point, like when we worked with these function calls, we often noticed that it would be very overeager in calling functions and even call them when it didn't really need to answer a question. Did you run into that at all, and or do you have any tips on how to prevent that?
Yeah. So this is a demo and it worked fine. So let me add that. And of course it doesn't have many functions. It only has like 7 functions. So the answer would be, I don't know how to prevent that. But what I learned is describe very well in your system message what it has to call and when.
Okay. Sorry, we have no time left. Big round of applause to our speaker.